In the Malaysian Form 2 curriculum, the Design and Technology syllabus contains a specific hurdle, electrical design. For many students, the complexity of circuit parameters leads to a disconnect before the lesson even begins. Electricity is a dynamic, invisible force, but classrooms usually attempt to capture it using static tools, textbooks, flat diagrams, and standard slide presentations. When you try to convey the movement of current through still pages, students quickly lose their motivation. They end up as passive spectators, struggling to visualize abstract concepts without a way to interact with them. The high rate of confusion here isn't a reflection of the student's abilities, nor is the subject matter inherently impossible. The friction comes entirely from a passive medium of delivery. Researchers Muhammad Afiq bin Umar Abdul Aziz and Dr. Abdul Muqsith bin Ahmad recognized this mismatch. They proposed a different approach. Rather than asking students to memorize a circuit from a whiteboard, they challenged them to navigate their way out of a virtual one. This idea led to the creation of Escape Electric, an interactive, game-based learning platform designed to replace standard lectures with exploration. By forcing players to move through the subject matter to find solutions, the platform shifts the educational focus away from studying electricity and toward the act of experiencing it. Looking at the platform's title screen, the shift in tone is immediate. The student's role changes from a reader to a player within a digital environment. This aerial map establishes the boundaries. Scattered red markers signify inaccessible areas. Every locked room represents an isolated learning activity. To progress, players must apply electrical principles to clear the obstacle and open the next location. The spatial layout gives the student a practical reason to seek out information. They aren't reading to pass a test. They are gathering the data required to navigate through the virtual world. When a student enters a location like this workshop, they encounter a contextual puzzle. The prompt at the bottom of the screen describes an object or a concept, and the player must identify it using visual clues. This interface introduces a 10-second time constraint. While the student analyzes a circuit diagram, they must quickly distinguish between series and parallel configurations. Selecting the wrong answer from these interactive buttons triggers immediate formative feedback rather than a penalty. The game halts their progress to provide specific hints and visual explanations, ensuring the player identifies the logic behind their error before they can try again. This loop converts a mistake into a learning moment. By providing a reason for the error in real time, the platform keeps the player engaged with the technical material until they reach a solution. Beneath the interactive surface lies a rigorous academic architecture. The platform was built using the ADDIE instructional design model, ensuring every activity is mapped to a specific learning objective. This comparative layout integrates technical schematics into the gameplay loop. The text beneath these diagrams provides context. To solve workshop tasks, students must cross-reference these schematics, understanding the differences in current flow and component arrangement. This approach requires students to apply electrical concepts to resolve practical problems in the environment, rather than memorizing formulas for a paper-based exam. By embedding the Malaysian syllabus within these interactive scenarios, the platform ensures that the students' progress is tied directly to their mastery of the curriculum. 5 expert design and technology teachers validated the platform, concluding that it improved student engagement and conceptual understanding while encouraging critical thinking skills. The deployment is also efficient. Because it is built on the GENIALLY platform, it requires no specialized hardware or software, operating entirely through a standard web browser. This framework can be adapted for other STEM subjects like physics, robotics, and technical vocational programs, using the same game-based architecture. Escape Electric serves as a scalable, cost-effective blueprint for digital education, providing a high-engagement alternative to traditional classroom delivery. When an education system relies on telling students what to memorize, the facts often fade once the test is over. But a student rarely forgets the logic behind a challenge they had to actively solve. True innovation happens when we stop simply teaching complex subjects and start creating the environments where students can experience them.